For millennia, humanity has looked to the stars, searching for answers about the future. We dreamed of a cosmic crystal ball, not through magic, but through the laws of physics. These laws seem to be a script for the universe, linking past and future in an unbreakable chain. Imagine a video of billiard balls colliding. Play it backward, and the laws still work. This time reversibility inspired scientists to believe that, with enough knowledge, we could predict everything. The universe became a colossal machine, every event predetermined, every outcome calculable. The dream, to know the cosmos's destiny, to map all of space-time. But this journey would lead us from classical certainty to the strange depths of quantum uncertainty. The Enlightenment brought a new vision. Newton's laws unified the heavens and earth. The universe became a grand clock, its workings precise and predictable. Planets, moons, and comets followed paths we could chart centuries in advance. Edmund Halley used Newton's laws to predict the return of a comet, Halley's Comet, proving the power of calculation over prophecy. This success cemented the belief in a deterministic universe. If we knew enough, we could predict anything. The same laws that governed the stars also governed atoms and, by extension, us. The future seemed encoded in the present, awaiting only our discovery. The only barrier was our limited knowledge, not the laws themselves. This set the stage for one of science's boldest thought experiments. Could we, in principle, know everything? Pierre-Simon Laplace imagined a vast intelligence, Laplace's demon, that could know the position and momentum of every atom. For this being, the future and past would be equally clear. By applying Newton's laws, it could calculate the fate of every star, every thought, every event. In this view, free will is an illusion. Every choice is predetermined by the state of the universe. We are cogs in a cosmic machine, our roles pre-written. This deterministic worldview empowered science but also stripped the universe of surprise. Yet, as our understanding deepened, cracks appeared in this perfect clockwork. The demon, it turned out, had a blind spot. The dream of perfect predictability unraveled with a flutter. In the 1960s, Edward Lorenz discovered that tiny changes in initial conditions could lead to wildly different outcomes, a phenomenon now known as the butterfly effect. Even in deterministic systems, long-term prediction became impossible in practice. The problem wasn't the laws, but our inability to measure the present with infinite precision. In chaotic systems like weather, minuscule uncertainties grow exponentially, overwhelming prediction. To forecast perfectly, we'd need to know the position and velocity of every molecule, an impossible task. For simple systems, small errors mean small mistakes. For chaotic ones, small errors mean total unpredictability. Laplace's demon relied on perfect knowledge, but reality denied us that. The universe's clockwork wasn't broken, just more intricate and sensitive than we imagined. The future was still determined by the present, but the present was unknowable in the detail required. Chaos theory dealt a blow to practical prediction, but determinism itself remained until quantum mechanics arrived. The next revolution would shatter the clockwork model at its core. The universe was about to get even stranger. Chaos theory limited prediction but didn't destroy determinism. The real upheaval came from quantum mechanics, the physics of the very small. At this level, the universe stopped behaving like a machine and started acting like a game of chance. Particles didn't have definite positions or momenta until measured. They existed in a haze of probabilities. This wasn't ignorance. Uncertainty was built into reality itself. Take radioactive decay. We can predict the odds, but not when a specific atom will decay. It's truly random. Laplace's demon depended on cause and effect, but quantum events could happen without a direct cause. The deterministic chain was broken. The universe wasn't just a machine with hidden gears, its parts themselves moved randomly. This fundamental randomness challenged determinism more deeply than chaos ever could. The future was not just hard to predict, it was genuinely unwritten. The crystal ball had cracked. The double-slit experiment reveals quantum strangeness. Fire electrons at two slits. Instead of two bands, you get an interference pattern, as if each electron passes through both slits at once. Try to observe which slit it goes through, and the pattern vanishes. The act of measurement changes reality. The universe seems to know when it's being watched. This is the Heisenberg uncertainty principle. You can't know both position and momentum perfectly. It's not a flaw in our tools but a fundamental limit of nature. Laplace's demon needed perfect knowledge of every particle, but quantum mechanics makes this impossible. If you can't know the present with certainty, you can't predict the future with certainty. The universe, at its core, keeps its secrets. The rules have changed. Randomness is now fundamental. The cosmic crystal ball is forever clouded. Einstein was unsettled by quantum randomness. He believed the apparent unpredictability was due to hidden variables, unknown factors beneath the surface. If we could find them, certainty would return. The debate raged. Was the universe truly random, or was there a deeper order? For decades it seemed untestable, a matter of philosophical taste. The universe's secret seemed safe until a new idea emerged. In the 1960s, John Bell devised a way to test for hidden variables. Bell's theorem showed that if hidden variables existed, certain inequalities would hold. Experiments repeatedly violated these inequalities, confirming quantum predictions. The universe does not behave as if hidden variables control it. The spooky action is real. Most physicists now accept that quantum randomness is fundamental. The universe plays dice, but the dice are loaded by strict probabilities. We can predict patterns, but not individual outcomes. Some fringe ideas remain, but the consensus is clear. The Clockwork Universe was incomplete. The cosmos is not a pre-written script. Reality is still being written, moment by moment. So where does this leave us? On the cosmic scale, Newton and Einstein's laws still let us predict with astonishing accuracy. The clockwork model works for planets and stars. But zoom in, and certainty dissolves into quantum probability. Perfect prediction is impossible. The future is a branching path of possibilities. This isn't disappointing, it's liberating. An unpredictable universe is alive, full of novelty and creation. The future isn't set in stone, it's a story still unfolding. We'll keep pushing the boundaries of prediction, but the universe's greatest secret may be that it has no final secret. We are part of an infinite, unfolding story.